All right, for 1-2, we're doing graphical transformations. So if you want to put 1-2 on your foldable, good idea. And what we are looking at are different rules that exist every time we graph. We're going to look at this over and over and over and over and over and over and over again, and for different functions, okay? So these are your rules. I would tell you to memorize them, but you will have a calculator to kind of help you cheat your way from memorizing them. I will say, if you memorize them, it does come easier though. Okay, so your up and down are on the outside, whereas your right and left are on the inside. That's going to make more sense in examples versus trying to talk about it right now. A reflection is when you have a graph that flips upside down this way for an x-axis. And then a y-axis would be like if the graph was going there, it flipped over there. That's a y-axis reflection. And then a stretch and a compression, or a shrink is what this notes calls it, is when you have a normal one, it kind of looks like this. A shrink is going to make it wider, whereas a stretch is going to make it skinnier. Okay? So, open up your notebook and let's get started. So, the absolute value function is a V-shaped graph with a slope of 1 and -1 going both ways. So, that would be this graph. I'm going to change my color here. If it is +2 on the outside, that means up 2. So, where I had this at 0, 0, it's now going to be up 2 at 0, 2. And then spreading out. And that's the only shift on that one. The next one is x squared. So x squared is a parabola that looks like this. Don't stress about how yours looks, because our entire next unit is about graphing these. So don't stress over that part right now. This one is down 3. Whoops, helps if I could spell down. So I just move it down 3. 1, 2, 3, 1, 2, 3. It looks something like this. Okay. These next examples are right and left. So an x cubed graph kind of looks like this, except I think that actually goes over here and this goes over here. So imagine it kind of... All right. Again, we're not going for perfection here. We're going that we understand that if it is minus on the inside there, so notice it changed to the inside. That means to go right to, that's actually opposite than what you probably think. So keep that in mind, that inside is opposite, if that helps you. A square root function looks like this. So in this example, +3 on the inside means left 3. So we take that shape and go left 3. Okay. So easy enough. Again, if you get stuck, use Desmos to help you. What if I wanted you to actually write the equation? So a V shape tells me its absolute value. Okay. So it goes right 1 and down 2. So right was minus and down was also minus. This one went left 2, up 3, and reflect across x-axis. So the reflect across the x-axis is a negative out in front of whatever symbols you're dealing with. And then up 3. So it might look something like that. We're actually going to skip example 6 solely because it's more of the same, but we're not really dealing with square roots until second semester. And while the rules are the same, I'm just trying to keep it a little more simple in 1-2. Okay. And non-rigid transformations are when they get, so let me go back to blue for the parent graph is what you may hear me call this, the original graph. Okay, so if you think about an XY table, if I did, let's do these 3 points. So 0 is still 0 because 0 squared is 0 times a half. -2 squared is 4, but half of 4 is 2. Same with positive. So now, all of this should be pink. Sorry, guys. Would be -2, 2, 2, 2, and 0, 0. So do we see how it is much wider? It is wider when you have a fraction out front. If you have a bigger number, so if you have a number like 2, 3, 4, 5, it's actually skinnier. So for instance, let's look at 2x squared here quickly. 0, 0. If I plug in 1 there, it's actually at 1, 2. And then if I plug in 2 squared is 4 times 2 is 8, it's even off the graph. So it's skinnier like that. Okay. Time's sake, we're skipping example 8. Feel free to raise your hand and you and I can work it together if you are just super curious. I don't want to squash that curiosity at all. All right, last thing, what if I give you some words and I want you to make the equation from the words that I said? So we know we're dealing with a parabola because we have y equals x squared. We want to shift left 1, so that is +1. A vertical stretch factor by 2, that's going to be a 2 on the outside. And a vertical translation down 3. Okay. One last example, except I would like, because this unit sometimes does absolute value as well, let's say that this one is an absolute value function and see how that's different, because really it's not much different. All right, reflect across the x-axis just means that there's a negative out front. Right 3 units means -3, and down 2 units means -2. So maybe I do this for you. 1, 2, and 3. And that is everything about translations that you need to know for 1-2.